So hello students, I hope all of you are well. So in my last lecture I have discussed about the lens formula. Okay, so I give you homework. I give you homework for finding the magnification, okay, of lens and derive the equation. Okay. Now in today's class I am going to discuss about the first I am going to discuss about the power of lens. Okay. Power of lens. Now, what is power of lens? The power of lens measured as the reciprocal of focal length. So simply, we can define the power of lens as the power of lens is measured as the reciprocal of focal length. That means power means how much can a lens can diverge or converge a ray. Okay, that is the power. That is the power of lens. Now, if f is the focal length, and p is the power, then according to definition, what is the power of lens? P equals to 1 by f. P equals to 1 by f. It is the by this equation we can measure a power of lens. Okay. Now the unit of power of lens is diopter. The unit of power of lens is diopter, or you can write capital D. Diopter or capital D. Okay. That means this SI unit. So what is the 1 diopter? 1 diopter means 1 by 1 meter. 1 by 1 meter. That is the 1 diopter. If the question can then define 1 diopter, then you have to write that the 1 diopter power is defined as the power of the lens which focal length is 1 meter. Okay. If the focal length of the lens is 1 meter, then the power of that lens is called 1 diopter. So this is about the power of lens. Okay. Now this is about the power of lens. So now I am going to discuss about the equivalent lens, or you can say combination of two thin lenses. When we place two thin lenses together, then it will give one combination of two thin lenses. Okay. Now we'll see how we can derive the equation for these two thin lenses. Okay. So we consider two lenses L1 and L2. Suppose O1 and O2 be the optical center of these two lenses, or you can get C1, C2. Now we consider one object, point object here, that is O. Consider one point object O. Okay, so A ray was incident on here, lens 1. After that it will reflect like this. So for lens 1, the image will be from here. Suppose it is I dash. Okay, for lens 1. Again, here for lens 2, from here I will be the image of object O for lens 2. This is the O is the object, point object, and I is the final image. Okay. For lens 1, the image will be I dash. Okay. For lens 1, the image will be I dash, and the final image will be I2. Okay. So this is U, this is V. Again, this is considered V dash. This is considered V dash. Okay. Now see, first we consider lens 1 for lens L1. For lens L1, suppose we consider. Here, what is the object distance? U is the object distance. Okay, and for length L1, what is the image? Which is the image? I dash is the image. So what will be the image distance? Here V dash will be the image distance. Okay, so for length 1, length equation will be is given by so what is object distance? U. What is image distance? 1 by V dash. Okay, let us consider suppose for length L1, focal length is f1. Thus we take for length L1, focal length is f1. Okay, so here 1 by V dash minus 1 by U equals to 1 by f1 from length equation. This equation for length L1. Okay, so give it equation number 1. Give it equation number 1. Equation number 1. Again, now consider length L2. For length L2 is L2 length. Okay, now you see for length L2, I is the image. Okay, I is the image, and for this length, I dash will be act as a virtual object. For this length L2, I dash act as a virtual object which gives the final image I. Okay, again listen carefully. For length L2, I dash will be act as a virtual object and I is the image. Now for length L2, what will be the length equation? What will be the length equation here? Object distance is 1 by V dash. Okay, it is act as object, so V dash will be the object distance minus 1 by V dash minus 1 by V dash plus 1 by V equals to 1 by F2. For length L2, take 1 by focal length is F2, so it will be 1 by V minus 1 by V dash equals to 1 by F2. Give it equation number 2. Give it equation number 2. Give it equation number 2. Okay. Now we add equation 1 and 2. Now add equation 1 and 2. Okay. Equation 1 plus equation 2. What will we get? It implies equation 1 is 1 by V dash plus minus 1 by U. Now what is equation 2? Plus 1 by V minus 1 by V dash. Okay. V dash equals to 1 by F1 plus 1 by F2. 1 by F1 plus 1 by F2. This cancel. This cancel. Okay. So this equation becomes 1 by V minus 1 by U equals to 1 by F1 plus 1 by F2. 1 by F2. 1 by F1 plus 1 by F2. Okay. Now if we consider that F is the equivalent focal length of this combination of lengths. Okay. If we consider F is the what? Equivalent focal length of these two lengths. Let me use this. Then from length equation, if F is equivalent focal length, then we can write 1 by V minus 1 by U equals to 1 by F from length equation. Okay. Putting these values here, so what will get? 1 by F equals to 1 by F1 plus 1 by F2. So this is the equation for combination of two lengths, that is 1 by F equals to 1 by F1 plus 1 by F2. Okay, now for what is 1 by F? 1 by F is P, power. So it will be P1, 1 by F1 equals to P1 and 1 by F2 equals to P2. So from this equation we can also write P equals to P1 plus P2. Okay, and for n lengths for n number of lens, you can write here. We can consider two lenses for n number of lens. We can write 1 by f1, 1 by f equals to 1 by f1 plus 1 by f2 plus dot 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 1 by up to fn. Same like this, 1 p equals to p1 plus p2 plus up to pn. This is the equation. Okay. So okay. So now I am going to discuss about the refraction through prism. Now what is first you have to know that what is prism. So prism is a optical instrument. It's like okay, just see this. This is prism. This is one optical instrument. There are three edges. This is this one and this one. Okay. If you see like this, then you can find that it is I have taken one equilateral prism. Equilateral means all sides are equal and all angles are equal. Okay. So this angle is called angle of prism. Okay, this angle is called angle of prism. So for equilateral prism, this angle will be 60 degree. Okay, 60 degree, and this all the face are called refracting face. Refracting face. Okay, and okay. So I have drawn here one prism. I have drawn like this. Okay, we take the prism like this. Okay, so A, B, C, this is AB, this is AC, and this is BC. See in the blackboard, this is AB, this is BC, and this is AC. Okay, this is one prism. Now we consider one ray PQ is incident first phase, incident at the first phase, that is AB. Okay, in this phase it is AB. So light goes from rare to denser medium. That means after reflection it will goes towards the normal. Okay, goes towards the normal. So this is PQ is the refracting incident ray, and QR will be the refracted ray. Okay, and this is I is the angle of incidence, and R1 is the angle of refraction for phase AB. Okay, you can see this one normal incident here. After reflection it will go towards the normal. Okay, here NO is the normal. Again for phase AC, R2 will be the okay, this is the incident angle, you can say, and this E is the angle of inversion. Here this goes from denser to rare medium, so after reflection this goes away from the normal. Okay, so this is the incident ray, and this will be the reflected ray. So light goes from PQ and emerge through RS, entering through PQ and emerge through RS. Now here angle A is 60 degree, B 60 degree, C 60 degree. Now see these two rays. Okay, this is incident ray. If we extend this incident ray in here, and if we extend the emergent ray, then the angle between the incident ray and the emergent ray is called angle of deviation. It's called angle of deviation. That means how much the emergent ray is deviated from the incident ray. Okay, that means this angle. If we extend this and this extend the emergent ray, then the other angle we consider is taken as the del, and del is called angle of deviation. Okay, so this is the ray diagram of a prism. Okay, ray diagram of a prism. Now we will derive the equation for Angle of minimum deviation. Angle of minimum deviation. Okay. So angle. Now you can see angle TQO is how much? TQO. This whole angle is equals to this one. So it will be I. It will be I. So if TQ is I, then TRQ will be, or TQR will be, TQR will be I minus R1. Okay, R minus R1. TQR, we have to subtract this angle from whole angle. So this whole angle is I. So we have to subtract this R1. So I minus R1. Again we can write angle TRO equals to E. Okay, TRO, this whole angle is E. So angle, we can write angle TRQ. How much? TRQ. If the whole angle is E, then it will be E minus R2. E minus R2. E minus R2. Okay. Okay, after this is okay. Now see, from triangle TQR. TQR. Which one? TQR. TQR. If you see, then this is the exterior angle, and these two will be the interior angle. Okay. TQR, this is the exterior angle and these two will be the interior angle. So we can write, what is the exterior angle? Del equals to what we can write? Angle TQR plus angle TRQ. TQR plus TRQ. What is TQR? We already got TQR. I minus R1 plus E minus R2. So from this we can write I plus E minus R1 plus R2. R1 plus R2. Yes or no? Okay. R1 plus R2. Give it equation number 1. Give it equation number 1. Again from triangle OQR. So from OQR we can write R1 plus R2, R1 plus R2 plus QOR equals to 180 degree. Equals to 180 degree. Okay. And we use this. So from this triangle you can find R1 plus R2 equals to triangle QOR equals to 180 degree. Give it equation number 2. Give it equation number 2. Okay. Now see. Now from quadrilateral, which one we consider? AQOR. AQOR. If you see the quadrilateral AQOR, this is normal, so this will be 90, and this is also normal, so this will be 90. So sum of these two is what? 180 degrees. Okay. Sum of these two will be, the angle is 180 degree because this is normal, this is normal. So this angle will be 90 degree. Both two angles will be 90 plus 90, 180. So if these two is 90, then this plus this also 90. Because we know the sum of the angle of the quadrilateral equals to 360 degree. Okay. So if this sum of these two angle is 180 degree, then A plus QOR equals to 180 degree. Equals to 180 degree. Okay. Is it clear? Okay. Now, from give it equation number 3. Now, see, from this equation 2 and 3, from equation 2 and 3, what we can write? From equation 2 and 3. So you can see here left hand side R1 plus R2 plus QR is 180 degree. Here A plus QR equals to 180 degree. So from these two equations we can write A equals to R1 plus R2. R1 plus R2. Yes or no? Yes, obviously yes. Because here QR is common. So if these two sides is 180 degree, then A must be equal to R1 plus R2. So from this we can write A equals to R1 plus R2. R1 plus R2. Okay. Now put this value in equation 1. So there will be del equals to how much? I plus E minus what is R1 plus R2? R1 plus R2 is A. Angle A. So from this we can write del plus A. Del plus A equals to directly like del plus A equals to I plus E. I plus E. Give it equation number 4. Del plus A equals to I plus E. Okay. I plus E. Del plus A equals to I plus E. So this here also in your final exam this question is kept. Okay. Now we will derive the equation for minimum deviation. Minimum deviation. Now, what is minimum deviation? The minimum deviation means if we plot the graph of between angle of incidence and angle of deviation, then you will find the graph is like this. I'm drawing here. So if this is I, this is del. So graph will be goes like this. Okay, graph will be goes like this. That means first you see the angle of deviation is increased with angle of incidence. When you increase the angle of incidence, the angle of deviation also increase. After a certain point, then again it will become increase with increase in angle of incidence. Okay, so this point where is the angle of deviation is minimum, that is called minimum angle of deviation. Okay, minimum angle of deviation. We will go on practical with this prism. You have to plot this graph. Okay. Now see. Now, if you can find if del equals to del n, at minimum angle of deviation, we can write or we can find I equals to E. That means at minimum angle of deviation, the angle of incidence will be equal to angle of emergence, and R1 equals to R2. Suppose we consider R, say suppose. At angle of deviation, R1 also equals to R2. Okay, that means if you consider this will be equals to this one, and this angle equals to this one at when the angle of deviation is minimum. Now put this value. From first we have put this value in equation. Suppose in this equation number 4. Give it equation number 4. So from 4 we can write from 4 we can write A equals to R plus R, R1 plus R2 and R plus R, so it will be twice R. A equals to twice R, and from this equation we can write del plus A equals to, so it implies R equals to A by 2. R equals to A by 2. So from this equation, del plus A equals to twice R, because I equals to E, so we have put the value E by I, so it will be I equals to, what will we get? Oh, it is del M, okay, because angle of minimum deviation, so it will be A plus del M by what? 2. A plus del M by 2. A plus del M by 2. Now see carefully. Now we know from Snell's law, mu equals to what? Sin I by sin R. Mu equals to sin I by sin R. From Snell's law. Okay. So put the value of I here. What is I? I equals to A plus del M by 2. And what will be the sin R? R equals to sin A by. So this is the relation between refractive index, angle of prism, and angle of minimum deviation. Okay, so this is very important. This year also this question came in final exam. Okay, so for today just go through this. Okay, in next class I will discuss about the dispersion. Dispersion. So for today, thank you.